I'm Anil Kumar sharing with you another brilliant question from one of our subscribers, Arum. Arum, thanks a lot for posting this question. Now it involves complementary sets, and that is a difficult topic to understand. And the question itself, I've seen it in many test papers, something very similar to this. So I hope it is going to help many of the viewers. So let's look into it and see how to solve it. Given that, now this symbol here corresponds to the universal set. So I'll say, given that the number of elements in the universal set is 23. Number of elements in the intersection of set A and B is X. Number of elements in A is Y. Number of elements in B is 2Y. And number of elements, which is intersection of complement of A and B, is 7. Find the least possible value of Y. Correct? Now, some of you who really understand De Morgan's law can easily solve this. Right? So let me write down here De Morgan's law. I'm not going to use De Morgan's law here to solve, but I'll go with basic steps. Right? So we'll kind of derive De Morgan's law in our approach to solve this particular question also. So let's say this is the universal set, and what we are given here is that total number of elements in this universal set is 23. And inside this we have two sets, A and B. Let's say this is set A for us, and let's take another set B. Right. So these are the two sets A and B, where we are given that the intersection, so when we say N intersection of A and B, we are actually referring to something right there in the center. So that has X elements, correct? So this becomes the intersection of A and B. Let me put arrows this side. Now, number of elements in A is Y. Now, if intersection has X elements, then the number of elements here will be Y minus X. So that makes Y total number of elements in A. Number of elements in B is 2Y. So we have 2Y minus X. So that becomes the distribution of our elements. Now we are also given one more statement here, and that is that the number of elements in intersection of complements of A and B is 7. Now this is sometimes difficult to understand. What does this mean? So when we say outside A, outside B and its intersection, we are trying to say this portion, which is kind of this portion. Do you understand? So it is this portion. That is what we are trying to say. And number of elements here is 7. Now from this figure it is absolutely clear how to get our equation. Total is 23 and not within these two sets is 7. So we get our equation, correct? So the total 23 should be equal to 7 plus what is there in both of them, correct? So the total 23 should be equal to what is outside these two units, set A and B, 7, plus Y minus X, plus X, plus 2Y minus X. Doesn't make sense to you. So this 23 total number of elements is what is not inside A and B and what is inside A and B. That is De Morgan's theorem. Do you get the idea? Right? So that is how we get it. Now, so we can actually write this 7 also as equal to number of elements which are not in the intersection or union of A and B. So the union of A and B is all this, and that portion which I've shaded is not in that union. So this is De Morgan's theorem. Do you get the idea? So if you apply De Morgan's theorem in one step, you could actually get your kind of solution, I should say, not exactly. But the approach which I am following here is easy to understand. Begin from the intersection, move out, try to get all the elements, and then you see the combination and the equation. Perfect. Now let's see how to solve this. So we have 23 equals to 7. How many y's? 3y, right? Plus 3y. Minus x plus x is 0, then we are left with minus x. Now we want to find possible values of y. So what we can do is, let's take x on this side and bring all these elements together. So what we will get here is x equals to 3y plus 7 minus 23. So x is equals to 3y minus, so 23, if you take away this, you get 16, right? Minus 16. Now number of elements cannot be negative, correct? So x value has to be positive. So x has to be greater than 0. That means that 3y minus 16 should be greater than 0. Do you get the idea? So from here we can get the least value of y. So this implies that if I take 16 to the other side, so we get y is greater than, let me write it in 2 steps, 3y is greater than 16, or that gives you that y is greater than 16 divided by 3. And you know y should be a whole number, correct? So that is 5 point something, correct? And that gives you the answer that y should be equal to 6. So the least value. Right, that is to say y is greater than, if you divide 5.33, something like this, so y has to be greater than 5 point something, so y should be equal to 6. That becomes the least possible value of y. Do you get the idea? Correct? So that is how you could easily solve this question. I shouldn't say easily, but that's kind of intricacies involved here. So it's kind of an inequality, which you can see how we can, work with the numbers given and get the solution. Perfect. Now the question for you is, find maximum value of y. Okay, so you can write in comments your answer about maximum possible value of y. The least should be 6. I hope that helps. Feel free to write your comments and share your views, and if you really like and subscribe to my videos, that'd be great. Thanks for watching and all the best.